Okay, so in this slide, the discussion is what is the direction of the induced current. Okay, so it's the same discussion that we had in lecture 3. So let's start from this figure here, this panel C, the figure C. What we have here is what we have this wire, it goes around, we get this loop, and then it goes out. And here I'm holding a magnet, but I'm not moving this magnet. I'm just holding it there. Okay, so this magnet, North Pole, that's where the magnetic field, the lines of magnetic field get out and then into the south. Okay, so I'm holding the magnet there. I have these lines of magnetic field going through the loop, but constant field, no current. And you see here, no current. Okay, now let's go to this scenario described in part A. What do we have here? Well, let's try to make a drawing. I have this loop now with the wire, and I have a magnetic field initially very far. Okay, so my magnetic field here is very far. So there are lines, but it's so far, no? The lines of magnetic field are so far from the loop that the magnetic field going through this loop is very weak. But then I will bring this magnetic field very close to this loop, okay? So this is my loop now. So very close, and now the magnetic field is going to get much stronger. And so instead of just these two dots that I put here, since it becomes much stronger, I'm going to illustrate that with many lines like this going through. Okay, the induced current is always trying to oppose the change. So how can I oppose the change? I started from this scenario where the magnetic field was very weak inside this loop to a scenario where the magnetic field became too strong. To oppose, I'm going to induce a current, okay? So I'm going to induce a current in this direction. Why in this direction? Well, if you use the first right-hand rule, so you put your thumb along the current and then use your 4 fingers encircling this wire, you will see that this current induces a magnetic field that is going into this page. So it's going to be making this magnetic field weaker. Okay, so the induced current opposes the change in the magnetic field, and the explanation that's the explanation for this direction. Okay, so this is what you're seeing here. As the magnetic field comes closer to the loop, we induce this current that goes in this direction, because current in this direction creates a magnetic field going down inside the loop, while we are making it stronger by bringing the magnet. We are making it stronger and stronger going up. So our induced current creates a field going down, opposing the change. Let's see now this case B. The case B, well, it's again similar, but now what is the story? Let's erase this. We start from this scenario. So let's make the whole drawing again. We start from this scenario where the magnetic field is already very close to our loop. Okay, so this is our loop. That means we have the strong magnetic field, okay, very strong magnetic field, because the magnet is very close. But then what are we going to do? We are going to bring this, well, take this magnet far away. Okay, so we are bringing this magnet far away. So we are making a change in this magnetic field. The magnetic field now is getting very weak. So what we want to do is what is going to happen is we are going to induce a current to oppose this change. So if we are going from strong to weak, I will now induce a current in this direction. Okay, so the current will be now in this direction. Why? Again, if you put your thumb here, you will see your fingers going from behind this wire and coming out. Okay, going from behind this wire, coming out. And so this will create this current, this induced current will create magnetic field lines coming out, making it closer to the initial scenario where it was stronger. Okay, so always the current tries to oppose the change. I think in lecture 3 it may be a little bit easier to understand the scenario.